All right, one more time. I'm going to go through the electrochemistry 1 lecture that we did in lab and just go through recognizing redox reactions, balancing redox equations, and then talk about the standard reduction potential table. So to begin with, we know about the different kinds of reactions: precipitation, acid-base, redox. Remember, redox is transfer of electrons. And the way we recognize it is to look at the oxidation numbers. So if those oxidation numbers change for an atom or an element, we know electrons are being transferred, and this is a redox reaction. So here's an example. Here we have iron 3. We'll review the oxidation number rules in a second. But iron 3 goes to iron 0. Remember, so there's a couple different ways we can say this. Leo says Gur is one, very similar to oil rig. So lose electrons, oxidation, gain electrons, reduction. Or oxidation is losing and reduction is gaining. Either way, if the oxidation number becomes less positive or more negative, you know they're gaining electrons, and that's reduction. Aluminum goes from 0 to +3. It's increasing, becoming more positive or less negative. That's oxidation. All right, and here we have an example of thermite. This is this reaction. Highly exothermic. They used to use it to, or maybe they still do use it to weld rails together. All right, so here's another example, another redox reaction. We have magnesium going to magnesium oxide and oxygen. And if we do the same thing, we assign oxidation numbers. Elements in their most stable form are 0. Ions in ionic compounds are the charge of their ion. So magnesium goes from magnesium 0 to magnesium +2. Oxygen is 0, and it goes to -2. Becoming more positive, 0 to +2, is oxidation. Becoming more negative or less positive is reduction. And remember, if something's oxidized, something must be reduced. All right, and what we're going to look at is how to balance those reactions. All right, so quickly to go over the rules again. The oxidation number of an atom in its elemental form is 0. So here's some examples. O2 gas would be 0. Sodium would be 0. Oxidation number of ions is equal to the ion's charge. So iron 2 would be +2, bromide would be -1, and potassium chloride, this is an ionic compound. We know that's made of ions, so it'd be +1 and -1. Oxidation numbers for common nonmetals. Basically what we're doing here is we're using H's and O's to help us figure out compounds. Remember, hydrogens are usually +1 in compounds, and oxygen is usually -2 in compounds. So we can use that to figure it out. So in this case, if I have +1 for hydrogen and -2 for oxygen, remember this 2 is important. The whole compound has to add up to the total charge. And this thing is neutral. So 2 + 1s is +2. And -2 for oxygen is 0, which we expect. Here, we're going to use oxygen is -2. That tells me that carbon must be +2. If hydrogen is usually +1, I have 4 +1s, that's +4. Carbon has to cancel that because, again, there's no charge up in the air here, so carbon is -4. All right, and there's some other examples, or other rules, like peroxide is O2 2-, but for the most part, oxygen is going to be -2. All right, let's practice this. So you take a moment and assign the oxidation numbers. Go ahead and pause me, follow the rules, assign these things, and then start me up again, and we'll check them together. All right, so if O is -2, and remember, these are always for individual atoms. Even though there's a 2 here, that doesn't change the oxidation number of oxygen. Where I need to use this 2 is that there's 2 -2s, so the O is contributing -4, so we need carbon must be +4. Potassium is an ion, be +1. Permanganate, we could also do this by itself, MnO4-. If O is -2 and I have 4 minus 2's, O is going to contribute minus 8. So minus 8 plus 7 equals minus 1, right? You want to think about it, plus 7. So plus 1 plus 7 is plus 8, with 4 minus 2's is minus 8. That whole thing is neutral. That's minus 2. This must be plus 4. Still minus 2, plus 1. This is going to contribute plus 2. O is going to contribute minus 6. So C must be plus 4. Mn is in his neutral elemental form, so he's 0. And sodium chloride, we know, is a plus 1 cation and a minus 1 anion.